Hello friends, so today we are solving this problem under daily LeetCode problem, bitwise OR of subarrays. So given an integer array R, so return the number of distinct bitwise ORs of all the non-empty subarrays of R. So the bitwise OR of a subarray is the bitwise OR of each integer in that subarray. So the bitwise OR of a subarray of one integer is that integer. Obviously the bitwise OR of 1 is itself 1. So what we have to do is we have to return the distinct bitwise ORs. For example, we can understand in this way. Suppose this is our array. Okay, so if this is our array, this has these values 1, 1, 2, 3. Now these many are the subset of this guy, right? The sub-arrays. Like we have this array, right? We have multiple arrays, sub-arrays. See here, this guy is one sub-array. Then 1, 1 is also a one sub-array. Then this 1, 2 is also one subarray. Then we have starting from here, this is 1, 1, 2 is also subarray, right? So every integer which is inside it, that itself also is subarray, right? Every like 1, 2, 3, all of them are a subarray in itself. So it can start from anywhere, can stop anywhere, right? So you can see here, these are all the subarray. Now in these subarrays, if we find the ZOR of all, not ZOR, but OR of all of them, then we have to find the what would be the distinct value. For example, let's say we proceed ahead in this itself. What would be the OR of this? The OR of this is this number itself, 1. OR of this is 1. This also OR of this is 1 only. OR of this is 2 here, right? And here if we do OR of these two number 1, 1 and 2, it would be 2. Similarly here it would be 3. It would be 3. This would be 3. So now you can see here that many times the values are repeating like 1 or 2 or 3, right? So the distinct value would be 1, 2, 3 only. So we have to return 1, 2, 3 only. We don't have to return all the duplicate OR values of these subarrays. So this is what we have to do. Now the thing is how to do that, because the one which I told you is just a kind of a brute force approach, because here we can see all the subarrays. And then what we did is we found the OR of all of them, all the numbers among them, right? Then we found that 1, 2 and 3 are the repeating everywhere. No other number is coming. So 1, 2, 3 are the 3 distinct numbers that are coming out of doing the OR of all these subarrays numbers. So we have to find, now this is a brute force approach, that's just for the sake of understanding I am doing in that way. Now the thing is, how can we do that? Right, so you guys can observe one thing here, that a subarray could be like starting from here, or it can be go for 1, 1, or it can be 1, 1, 2, or it can start from here, like these, all of them here. These are starting from anywhere and ending at anywhere. So what we have to do here is, in this approach, we have to take care of one approach here. For example, at any ith index, okay, suppose we are at this guy. So at any ith index, we will look for the left side, whoever is the left side element. We will check that what all subarrays are ending at here. Okay, so what we will do is we will get a set. Okay, let's say we will call it this set equal to cur set. So what we will do is in cur set we will keep the OR values of all the subarrays which are ending. Let's say if this is I, then whoever is ending at this I minus 1. Okay, so whoever is ending all the subarrays, we will keep the OR of all those values into this curve. Now you guys can understand that whoever is ending at I minus 1, all those subarrays can also include this guy, because that is also adjacent. We are creating the subarrays, so it has to be adjacent. So this guy, ith guy, can be included with all of them. Okay, so suppose in this curve we have 3 values, OR1, O1, O2, O3, like this, right? That means all these OR values that we have calculated till I minus 1th location, we have to do the OR with this guy, right? Because this also can be the part of all these subarrays, because these subarrays are the list of the subarrays which are ending at I minus 1 location. Okay, so in this way, whatever, so let's take the real example of it. So when we will start here, first of all we are starting with the 0 value. Zero value is the like initiation, because with the zero value, if we do the OR of any number, it is same. So when we will start from here, we will do on the left side there is no subarray, right? So we kept here 0. So if we do the OR of this guy with 1, what would be the value here? So at I equal to 0, if we do the 0 with 1, so this will give us 1 only, right? So this will give us only one value, 1, right? Now we will come to this guy, second location, right? So we have already in this car, we have this one. So what we will do is we will create a next set also, because this next set would be give us the next set of car values. So in this next, what we will do? So in this next, whatever is the I we have, let's say here we have this I equal to 1. So at I we have one value. So let's say we have added already this guy 1. Now for this one value, in this we have to do the OR with all those which are ending here, right? So ending at I minus 1, we have this curve, right? So we will do the OR with all of them. So this will give only the one value, this guy 1, right? And the another one, this 1 and 1, right? So these would be the two values that we have. But because this is a set, we are interested only the unique value. So this will give us only this one, right? So in this set, now we will keep on adding them in an answer set, right? Let's say we will have a answer set also. So this would be the answer set, that every time we are making the value here. So in next, whatever is the next, that we would be adding to the cur. Okay, this value would be added to the cur, and for next value we will reset this next and again start and keep on assigning this cur. So now this cur would be, we will assign this value, right? And from this cur we will be put this or all the values into the answer variable. Now we will come here, let's say we are reaching here at 2. Okay, so when we will come to this next would be having only 2, right? Then with this 2 we will do the OR operation with this cur. So cur have right now only this one value, right? The current cur has only this value 1, and when we are reaching at this 2, right? So our next would be, first of all we will add whatever that value. So it would be the 2, because OR of this subarray, it with itself would be 2 only. Now we will do this OR with the whatever value is there in the cur. So 2 OR with 1 will produce 2 only, right? So we will be having this 2, but because this is an set, so it would be having this value 2 only, right? So we would be having this value 2, and we will add this value to here, right? Now our whatever the next has, this next we would be adding directly to this cur. So now what would be having cur? The cur value would be updated with this next. So this guy would be having, cur would be having now 2, and next would be again reset, because we are coming to I equal to next value. Okay, so finally we are coming at this location, right? So at this location what will happen? This is 3, and we will check that what all is ending here, right? So there are ending 2 values, right? This is the 1 and 2, the OR of 1 and 2, and the value of this 2 itself. So this is unique value only. So when we are coming to this guy, first of all we have to add this value. So 3 would be the value which we have add into the next. Now with this 3 we will do the OR with this 2. So if we do the OR with the 3, it would be 3 only, right? So this 3 we will have the single value only, because this is also set. And now this next we would be assigned to this cur. So this cur would be having 3, and every time whatever cur value has, we will be adding to the answer, right? So we will add this guy also, and our next would be reset for the next iteration. But by that time our array itself is done. So we are coming out of this array, and this would be answer. So let me write the code so that you would be making the great sense. Okay, so first of all what I will do is we will create the this hash set. So hash set cur. So this is the set of integers. So hash set cur equal to, we will write new hash set, right? So this would be our hash set. Similarly we will also create an answer hash set. So let me copy this guy itself, and I'm pasting it. I'm calling it answer hash set, because we need both place these guys. Now this next would be created every time. So what we will do here is, first of all we will traverse through this array. So for int I equal to 0 to I less than whatever is the length of this array, length, and I plus plus. Okay, so here what we added, right? Initially we started this guy with adding the 0 value here, right? So same thing we will do here. So what I am doing here is, let me add in the cur dot add I'm adding 0 here. So I have added here 0. So let me make it here like this. Now we guys are coming here. So first of all what we will do, whatever value we have, let's say first of all we have to create the hash set next equal to, right? We were calling it next. So next equal to new hash set. Okay, spelling is wrong here. Let me correct here as well. Similarly I have to correct it here as well. Okay, now we have this next every time. So first of all what we will do, as soon as we are coming to the next, we were adding the whatever value it has, whatever. So we are starting here. So in the next what we will add here, first of all we will add whatever is the value at this guy. So it would be I, right? So we are adding that guy first of all. Now initially we have only this guy, right? So when I equal to 0, there is no subset which is on the left side. So that is why we added this 0, because 0 doesn't make any difference if we are doing OR with any number. It gives that number itself. Okay, so what we will do here is, we will traverse through this cur value. So let's say we have int x in the set cur. Okay, so we were traversing through all the values which are ending at the I minus 1 every time, and then we are doing the OR of all those numbers with that x, right? So what we will do is, we will add this guy. So next dot add whatever is the air I, because air I is the current element that we are encountering, and we will doing the OR with this guy x, right? Because we are see here, this cur is the like set, it would be having multiple values. So for all of them we are doing the OR and adding into this next, right? So once we will come out of this loop, what we will do is, whatever value we have in the next, we will assign this value to cur. Okay, because cur now would be having all those guys who are ending at this current I. So that is why I am assigning. So what we will do here, cur equal to, we will do next. Now whatever so far we have found in this cur, we have to add into the answer set. Okay, so answer dot add all, which will be add all the values of this cur. So let me add it here. So now you can see here, this cur is setting to this next, because we have to find the all values who are ending on the current I. For the next iteration it would be helpful. And now whenever this for loop text values you see here on line number 8, this next is always starting with a new hash set. Okay, so in this way we are having finally, now what we are returning, we are returning the distinct value. So this distinct value would be equal to the whatever answer set has, whatever would be the size of it, that many values we have distinct. Okay, so let me execute this code. So I am executing this code, and okay, so there is some so one semicolon we have missed. So let me put this semicolon here. Now we will running it. Okay, so let us see. Okay, return statements. Okay, we have not written it, the return statement. So now it should be correct. So let me execute this code. Okay, so let me submit it. So I am submitting it. Let us see what happens. Okay, so it is submitted. So now guys, wait a minute. What would be the time complexity? That is important, because in your interviews the interviewer would be definitely asked this question, that what is the time complexity here. So if you look at here, it looks like any square, right? Because this is a for loop, and this is also another for loop, which looks like this would be quadratic. But wait a minute, we are doing the OR operation here, right? And OR operation means it is not drastically increasing, because this numbers might be, let's say if we look at the range here, see here, these air numbers is going only up to 10 to the power 9, means this would be close to 30 bits, right? Now some of you might have questioned that how can I see this would be 30 bit. So to get that how many bits would be required for a number, that we can do using the log. If we do the log of 2 base for that number, this will give us what would be the total number of bits. Okay, so if we put this 10 to the power 9, it will give us 31 bits. Okay, I think 32 you can put it into. So let's say in general we are taking 32 bit. Okay, suppose we have 8, right? Suppose 8 is the number, maximum number, then it can return at 2 to the power 3. So it would be, its value in the logarithmic would be, log base 2 would be 3, right? So same way, what is happening is, whatever is the maximum value in this array, we cannot go more than that. More than that, means the log of whatever is the maximum value. Okay, so let's say max is m, so log m, n log m would be the answer here. Now because this range is coming between 32 bits, right? So it would be n log 2 to the power 32, right? So this would become 32 into n. So time complexity would be 32 into n, which would be of equivalent to n only. Okay, so this is important. So guys, so thank you for watching this video, and those who has any concern, please make a comment over there. Thank you.